Finally, the moment we've all been waiting for. Dividing polynomials. Woo! Woo! Alright, don't get that excited, right? It's not that exciting. But if you really don't like this chapter so far, this is the end of the chapter, if that makes you happy. But if you've enjoyed this chapter, I'm sorry, you better really savor this last section, because we'll be moving on to bigger and better things. Well, the next chapter, though, keep in mind, the next chapter will be probably the most important thing we learn in this entire class. The thing that you'll be using all the time in your next math class. So at least you'll know you'll be moving on to something very important and something you should really pay attention to. This stuff is important, but you won't use it as much as the next chapter. Alright, so dividing polynomials. In this section, it's kind of broken down to two different parts. Because if you're dividing by a monomial, remember a monomial has one term. It's very simple because you can use this property. Because remember, if you have a fraction, you got two things maybe adding on the top. If you only have one thing in the denominator, what you're thinking of that is like in this first example here, you're dividing a monomial, that's only one term on the bottom, into a polynomial. You can use this trick or this nice property that as long as there's only one term in the denominator, you can split the fraction up, give each term in the numerator its own denominator, and then simplify each one separately. We'll have to come up with a different way to do it though, just in case your denominator has more than one term. Like we got lucky in this one, 3x squared, that's only one term. But like the property shows, we can do exactly the same thing as the property. It's like, okay, we have two terms in the numerator. There's a 9x to the 5th, and there's a 24x to the 8th. There's two terms, and since the denominator only has one term, you're free to split this into two fractions, where each of them gets their own denominator. But yeah, this property can only be used if the denominator has only one term. So that's keep that in mind. We can split a fraction that has one term in the denominator. If it had more than one term, we cannot split the fraction. And we'll see what to do in those situations. It'll be more complicated, but at least we can savor these problems while we have them, the ones that are nice and simple. Okay, now that we've split it up into two fractions, really this is kind of like in the beginning of this chapter where we used our exponent rules to simplify. So I think we've seen, say just this first fraction, that's like a problem we saw in that section where we practiced our exponent rules. And then same thing here. So it's almost like they just took two problems from those exponent rules section and put them together. But of course, so the numbers in the front, the coefficients, you can combine those. So here you have a 3 dividing into a 9, that makes 3. And then as far as the x's go, remember the property, if you're dividing an x to some power divided by another x to some power, all you have to do is you subtract their powers. Remember, you subtracting, that was one of our exponent rules that we haven't really used yet, so it's easy to forget the exponents. Okay, so this first term is going to be 3x to some power. You're going to take the first exponent, 5, the numerator's exponent, and subtract the denominator's exponent. And that, you don't have to write that out. You can do that in your head. You can say, what's 5 minus 2? Oh, that's 3. No need to really write that out if you don't want. Now we'll do the same thing with the second term here. I can divide 3 into 24 is 8. And then I'm going to subtract their powers as well. The exponent on the top is 8 minus the exponent on the bottom is 2. 8 minus 2 is 6. So there he is. 3x cubed, or 3x to the third plus 8x to the sixth. And probably just because this only has one variable, I'm going to write this in descending order of powers, because that's how they like to see these. Alright, that's really it. So that one it's not too complicated, as long as you remember that only monomials have that property where you can split it into two fractions. Let's try this next one here. Part B looks way more complicated. It'll just be kind of a souped up version of the last problem we did. How many terms are on the top here? 1, 2, 3, 4, 5. Because remember, one term starts and only ends when there's a plus or a minus. So I see 5 terms. That means I'm going to have 5 fractions here. I see a plus, and I'm keeping the same signs. Plus a second fraction, then there's a minus, so I'm going to keep the minus. The next sign's a plus, so there'll be a plus. And the last sign's a minus, so there'll be a minus in between the last two fractions. But all their denominators are going to be that same denominator from the original fraction. Minus something with that denominator, plus something with that denominator, minus something with that denominator. And those somethings are just the terms. So the first term in the numerator was 12, x to the 7th, y to the 3rd. And the second term, I kind of wrote over it, sorry. It's x to the 6th, y. Let me see, I don't think we had an exponent on y, right? Did we? No, okay, good. The third term was, let's see, 4x to the 3rd, y to the 5th. The fourth term, 2x squared, y. The very last term is 3x, y to the 6th. And I'm glad we already took care of all the negatives and the positives, so I don't have to worry about that. They're all taken care of here as the signs between the fractions. Alright, it looks good. Now it's just a bunch, let's say five problems put together of exponent rules. Let's see what we get there. So the first one, I can reduce the 2 and the 12. 2 can go into 12 6 times. The x's, okay, again, you're going to subtract the powers, and you don't have to write the step out if you don't want, but I'm just going to write it out so you remember where it came from. It's x to the power of 7 minus 2, because that's the exponent on the x on top and the exponent of x on the bottom. And then y to the power of, it's 3 on the top, 1 on the bottom. Even though it's invisible, it's an invisible 1. Okay, then what? Let's see, you have, The next one, notice there's nothing for the 2 to reduce with. So the 2 will have to stay in the denominator. He has nowhere to go. There's nothing to combine with or reduce with. Let's see, so, And you know what you can do actually is write that guy as a 1/2. Because I think it would look weird if I just go something over 2 and then x to the 6 minus 2. You know, that kind of thing. I'd say, wait, what the heck is in the denominator? But if you want, you can think of, even though I don't see a coefficient in the numerator there, I can put an invisible 1. Because every variable has an invisible 1 coefficient. That means it's the coefficient of my resulting term will be 1 over 2. Because that's what you get here, 1 over 2. And then the x's, like we said, we're going to subtract their powers, 6 minus 2. The y's, you can do the same thing if you want, or you could just cancel them. Y and y cancel. Or you could say, oh, their powers are 1 and 1, so I'm going to subtract their powers, 1 minus 1. Alright, the next term, this one, the coefficients go in evenly. There's a minus as well. 2 goes into 4 twice. The x's, I'm going to subtract their powers. It's a 3 on the top and a 2 on the bottom. And then the same thing with the y's. I'm going to subtract their powers. You have a 5th power on the top minus a 1 power on the bottom. Kind of an invisible 1 power. Alright, then the next term here, the 2's just cancel all together. And there's a plus in the front, so I'll still have a plus on mine. You can think, I guess the x's cancel, or you can do x squared minus 2. You know, you're subtracting the powers, or you could just cancel them. Same thing with the y's, they just cancel, or you can say it's y to the 1 minus 1. Either way, we're going to get the same answer. Alright, then the last term here, what is he? So the 3 and the 2 don't reduce, I'll just leave it that way. Minus 3 over 2. The x's, I'm going to subtract their powers, 6 minus 2. And the y's, actually, their powers will cancel. Wait. Oh, shoot. Just now I wrote the power. I was kind of reading this wrong. In the original problem, the 6th power should be on the y. Oopsies. So I should be subtracting the x powers. I'm sorry. X's exponent on the top was a 1, because the 6 wasn't for the x, it was for the y. On the bottom, it's a 2, so you're taking 1 minus 2. And then for the y's, let me see, I'm subtracting their powers. The numerator has a 6, and the denominator has a 1. Alright, and this might be more work than you really have to show. You can just subtract them in your head and write the results, as you go. So, okay, this first term is going to be 6x to the 5th when I subtract y squared. The next term is going to be, I'll keep the 1/2 the same, x to the 4th, and notice y to the 1 minus 1 is 0. And then in the next step, or the last step, we'll have to remember what the heck does that mean. The next guy is minus 2 x to the 1, but I'm just going to write x, because x to the 1 looks sloppy. Y to the 5 minus 1 is 4. So that's that term taken care of. The next guy has an x to the 2 minus 2, that's another 0 power. Y to the 1 minus 1 is another 0 power. Interesting. And then the last guy, the 3/2, there's nothing we can do with that, I'll just leave him. X to the 1 minus 2 is negative 1. Oh, interesting. y to the 6 minus 1 is 5. Alright, there's just a little bit more cleaning up we can do, and then I think we're pretty much done with this one. The first term, there's not really much I can do with it. I think it's perfect the way it is. The second term, however, you can just say, you know what? 1/2 and x to the 4th, there's not much you can do with them. But remember, what is anything to the 0 power? It's 1. So y to the 0 power is really just a 1. Alright, and then the next term, I think there's nothing much we can do with that. There's no 0 powers and there's no, I don't know, there's not really much to do with that one. The next guy, it's just made up of x to the 0 power, which is 1, because again, anything to the 0 power is 1, times y to the 0 power, but that's another 1. That term just ends up being a 1 times a 1. And then the last guy, you got -3/2. And remember, you have a negative power. Whenever you end up with a negative power, we don't want to see that in the actual answer, so I'm going to rewrite that guy. Remember, x to the -1 power means 1 over x. And then y to the 5th, he's perfect the way he is because it has a positive power. Alright, I'm just going to clean this up and write it one more time. So we already said the first term was good the way it was. I'm going to leave him as is. The second term, I don't really need this 1 because 1 times anything is that thing. I'm just going to drop it. The next term was perfect as is. The next term is a 1 times a 1, which is just 1. The last guy, though, I might multiply across here. I'm going to put this y to the 5th over 1 so I know what to multiply across. In the numerators, I have 3 times 1 times y to the 5th. That's 3y to the 5th. In the denominators, I have a 2 times a x times a 1. That's 2x. And that looks good, I think. That's a really complicated looking answer, but it's probably as bad as those get when you divide a monomial into a polynomial. But I think there are a lot of steps in that you can skip, you know. And remember earlier, just to point it out, hopefully this helps. Where was it? This step here we had. Remember this term? It was 2x squared y over 2x squared y, and we said, oh, you can just think of everything they're canceling. The 2's cancel. X squared cancels with x squared, y cancels with y. So you know in a fraction, if everything in the numerator cancels with everything in the denominator, a 1 is left, right? So you could have saved yourself a lot of headache. All these steps right here could be thrown out if you just remembered that, and you could have had a 1 from the very beginning, and you would have known what that term was. So I might have saved you a little headache, but just know that no matter which way you go, you cancel everything or you use exponent rules, then either way it's going to work. So don't worry, either way you do it, it's going to work out pretty well. That's why math is nice. Okay, so now that kind of shows us how to divide a monomial into a polynomial. But then the next thing we have to do is we have to consider how are you going to divide two polynomials if the thing you're dividing by is not a monomial. Because a monomial is nice, but anything like a binomial, trinomial, God forbid a four-term polynomial, it's going to be more complicated. And unfortunately, the way we're going to have to go about it is we're going to have to use like a long division. So it'll be, I know this seems silly, but doing this long division problem, even though these aren't polynomials, it'll kind of give us an idea of what our problems are going to look like, and it's good review as well. So if you're dividing something into something, you place okay, this is a good thing to remember too, because we'll be using these words. Remember that the thing you're dividing by, he's called the divisor, because we'll be using that word to describe all the operations we're doing. And the number you're dividing into, which in this case is 8,795, that guy's called the dividend. Just the number you're dividing into. And then whatever the result that we get when we divide, the thing that's up here will be the quotient. So when we write the directions on how to divide these polynomials that are not monomials, we're going to be using those three words. So just so you know what they mean. Divisor is what you're dividing by. Dividend is what you're dividing into. Quotient is the result of dividing. Alright, let's try this. So remember 31, okay, you look at the first digit, you say 31 is too big to go into 8. Let me add another digit. 31 can go into 87. How many times? I'm going to try it off to the side. 31 times 3 maybe? Let me try 31 times 4 to see how that works. That's going to be way too big. Nope, must be 31 times 3. Okay. Oh wait, what the heck? 93. I'm losing my mind, you guys. That's too big too. 31 times 2. Hello. So 62. Okay, must be twice. And remember, you put the quotient right above the right digit of the number you're dividing into. So since I'm only dividing into 87 right now, I'm putting the 2 above the 7. So first thing you do is divide. You're kind of dividing your divisor into the first portion of the dividend. Not the entire thing right now, but just the first portion of it. And once I divide, now I'm going to multiply, right? The 2 times the 31 makes 62. And then I'll subtract those guys. When you subtract those guys, you get 25. Alright, so remember, it's like, the steps are kind of like you divide. Even though you're not dividing the entire, into the entire dividend, you're still dividing, and then you're multiplying. Because we'll be using these same steps for polynomials. Alright, now that we've multiplied, then you subtract, which is the last thing we did. And if you remember, the next thing you do is bring down the next digit. So we've already looked at the 8 and the 7, but we haven't looked at the 9 yet. He's the next guy to bring down. And then you start over, right? You start over back at dividing. Start the process over. So we'll be doing the exact same thing, but with polynomials. That's why it's good to keep those steps in mind. Alright, 31 into 259. That's going to be pretty... I'm going to have to try that over here. 31 times... I don't know, let's try 8. For some reason that's speaking to me. 8 times 1 is 8. 8 times 3 is 24. Oh my gosh, I think that's as close as we're going to get without going over. So it must be 31 into 259 is 8 times. I'll put that here. So we divided. Now we're multiplying. 8 times 31 we just found out was 248. The next step we'll subtract. That'll be 11. And we'll bring down the next guy. And remember, you know you're done, or you're almost done, when you're bringing down the last digit. So 5 is the last digit. That's how I know this is the last time I'm going to repeat this cycle here. 31 into 115. Let's see. I can use the work I did earlier. 31 times 3 was 93. 31 times 4 was 124. That's a little too big. It's larger than 115. So I must want 3 here. So okay, the quotient will be 3 for that portion. Now I'll multiply. 3 times 31 is 93. And then subtract. Let's see, that's 22. Alright, and we could keep going if we wanted to, you know, put a decimal and then bring another 0 down, etc., etc. But just for the sake of these problems, we're going to be actually, in these polynomial problems, we're going to be writing our answer with a remainder. So remember, that means that the answer is going to be the quotient, 283. And then the way we're going to write our answer in these problems is plus the remainder, 22, okay, because that was what was left over the dividend, or sorry, over the divisor. The divisor was 31. So that's how you can write your answer. 31 goes into 8,795. It goes in 238 times with 22 left over. So that's the idea. We're going to try that with polynomials now. It takes some getting used to, and you got to be really careful. It's easy to make a mistake on these, and I'll show you exactly where the mistake is probably going to be made. Alright, let's see these guys. So just look at an example. We're not going to do it yet. We're just going to look at it. Let's see. Example 2, part A. Look at that guy now. Okay. It's x squared minus 8x plus 12 divided by x minus 2. So notice you're dividing by a binomial. That means I can't use the method I used in the first example where I split the fraction up and all that. It's not going to be possible. I'm going to have to do long division here. So how about as we go, I'm going to just kind of do these steps as we go with this example. So our first step here, step 1 says, you're going to set up the long division, making sure to write both polynomials in descending order of exponents. So notice in the example we're given both polynomials, the x minus 2, that's in descending order of exponents, so we're pretty good there, as well as the dividend x squared minus 8x plus 12. They're both already in the right order, so I don't have to worry about that, but maybe, you notice in problem part D, the terms are not in the right order. You have x and then 6x to the 4th. So that'll be a problem later, but for now we don't have to worry about that. So we've got descending order of exponents. This we don't have to worry about yet either, but in future problems we will. It says here in part 1, or step 1, if there are any missing exponents from highest to lowest, place that, or sorry, we'll have to see what to do there. We'll have to place that term with the 0 coefficient. So even though we don't see that right now, it might help for future problems to, like, even imagine what the heck are they talking about, missing terms. I guess, like, let's say, for example, what if one of my, maybe my divisor is, let's say x cubed plus 5x minus 1 or something. So you notice from the highest power, which is an x cubed, to the lowest power, which is the constant, I'm missing one power, the squared term. Because I guess what you want to see is from the highest power to the lowest power. This guy's exponent is 3, this guy's exponent is 0. You want to see all the successive powers in between. I want to see not only a cube, which is what I'm starting with, but a square. I don't see that. A 1 power, I do have that. So what we would do in these problems, if you happen to be missing a term from the highest to the lowest, is we're going to insert our own there. So it'll be x cubed. We're going to give ourselves an x squared, and then we'll write the other terms. But you can't just write a new term and expect it to be the same thing. You know, this is now a totally new problem. But the way to fix it is to say I have 0 x squareds. Because 0 times anything is 0. So that's what we're going to have to do in these problems. And we'll see why. It's because if you have a missing term, like if I left it as x cubed plus 5x minus 1, when I do the long division, my terms won't line up right, and the whole problem will be messed up, because you're going to want to see like terms above and below each other vertically. And if you don't write any missing terms like we have here, it's not going to work out right, and everything's going to go bad. So for now, though, we won't worry about it. We don't want to. It's already complicated enough as it is. We'll worry about that in a later problem. So for now, I think we're good. Notice in the dividend, we have a second power, a first power, and a 0 power. So there's nothing missing from the first to the last. Second power, first power, 0 power. Same thing in the divisor. I have a 1 power and a 0 power. There's nothing missing in between those, a 1 and a 0. So I'm all done with step 1, okay. Step 2 says you're going to now look at the first term in the divisor. Let me see, I'm going to erase these markings so I don't confuse myself. Remember, the divisor is the thing outside the parentheses, so I'm looking at the first term. Where is that guy? X here. You're looking at him, and then you also look at the first term in the dividend. So I know there's a lot of terms hanging out here, but you're really only focusing on the outer guy, the very first guy, and the inner term, the very first term. So look at those guys, and then you're going to decide what their quotient is. So you say, what's x divided into x squared? And if you think that's kind of weird, you can always go off and think about that. What would x divided into x squared be? That's really what you're doing. And you can use the exponent rules. You would subtract the exponents. X to the second power minus 1 power is x to the 1 power. So really it's an x. X goes into x squared x times. And that makes sense actually, because what if you multiply those guys? X times x, that is x squared. So of course that must be how it divides. X goes into x squared x times. Alright, and then as it says, we kind of jumped the gun there, but we've done long division before. You're going to place this term above the corresponding term in the dividend. So that's what we've done. I divided x into x squared, and I've got x. So I'm putting that above what I just divided it into. Alright, now we can move on to the next step. Now you're going to multiply this term that you just wrote, the red x, by the divisor. Okay, but notice the divisor, it's x minus 2. There's 2 terms there, so you're actually going to have to distribute, right, or multiply this x by both terms. And if the divisor happened to have 3 terms, I'd have to multiply by all 3 of them. So I'm going to multiply those guys and write it below the dividend. So first I have x times x, that's x squared. And then I have x times negative 2, that's going to be negative 2x. Okay, so we've done that. The next step, step 4, says you're going to subtract the result from the terms above it, being careful to distribute the subtraction sign. So this is where people make mistakes. This is where I put exclamation point right here, because yeah, I think mostly people do this process right. Maybe they make silly mistakes here and there, but they mostly do it right except this part here. What we want to do is, like we did in regular long division with the numbers, subtract this guy. But since there are 2 terms here, you have to think of it as in parentheses. I'm subtracting this entire thing. So you have to think of it as distributing this negative here onto both. So really, that kind of makes this guy a negative, and it makes this guy a positive, because you distribute the negative onto both. And now you can kind of combine vertically. You have x squared minus x squared, that's nothing, they cancel. And then you have a negative 8x plus 2x. It was a minus, but now it's a plus. Negative 8x plus 2x is negative 6x. Or if that kind of seems like a lot to process, you know what you could do also? Let me see here. I think that's probably the best way to do it, but if you don't like that, you could always go, okay, because I shouldn't have erased all that, because what was in there? X squared minus 2x, okay. If you don't feel like you want to distribute the negative, what you'd have to do is you'd say, okay, x squared minus x squared, okay, those are gone, and then you have negative 8x minus negative 2x. You'd have to consider this minus outside and the negative inside. So if you can do all that in your head, negative 8x minus negative 2x. That's negative 8x plus 2x So I really have to consider this sign and this sign together in one. So I think, for me, I always distribute that minus sign, make this a plus so I don't mess up. But it's optional. You can always think about it. Minus and negative and all that. Alright, that's the trickiest part. It'll get easier the more of these we do, though. And then the next step, we've subtracted, and we were careful to bring down to distribute the negative. Now the fifth step is we're going to bring down the next term. So you've already taken care of the x squared and the 8x. The last term here is a plus 12. Alright, so we've done step 5. Now let's look at step 6. It says to repeat the steps, you know, like kind of like we wrote above. Remember when we did long division, we said these are your steps here. Divide, multiply, subtract, bring down. Those are really what they're talking about when they say steps 2 through 5. Oops. It's like, oh shoot, sorry. The next step is going to be to divide. And you're still kind of doing the same thing. I'm going to focus on, like it said to begin with, the first term in the dividend, x, or sorry, the first term in the divisor, and then just the first term of, I'm not even going to focus on the 12 right now. Don't worry about that guy. Just say, what's x, the outer guy, divided into negative 6x. And if you think it's weird to divide like that, like I said, go off and try it over here. What's x divided into, x divided into negative 6x. Well, the x's would cancel, right? So all you'd be left with is the negative 6. So that would be my quotient right there. Minus 6 will go above that on the quotient. And then my next step will be multiply that negative 6 by both terms in the divisor. So let's see. I'm going to go multiply. So this 6 that I just wrote, think of it also as a negative 6, not just a 6. Negative 6 times x will do that, and then negative 6 times negative 2. So okay, negative 6 times x, that's negative 6x. Negative 6 times negative 2 is positive 12. Alright, we're almost done. I can tell we're almost done. Like the step 7 says, you're going to continue this process until there's nothing left to bring down. And I noticed I've already brought down the last term, 12. So I know I'm almost done with this process. I just have to finish my subtraction here. I'm going to subtract these guys. You could do it like this. You got, okay, the negative 6x minus negative 6x. What's negative 6x minus negative 6x? That's like negative 6x plus 6x, so those cancel. But then as far as the 12s go, it's 12 minus 12. Even though that minus is far away, it's meant for this 12. So I'll probably distribute it, make this a negative 12. That way it looks more like 12 minus 12 is 0. Alright, so we're all done with the division because there's nothing left to bring down. Now all that's left is to just try to write our answer in the certain form, like it says here in step 8. Kind of like we wrote our answer in that long division problem. You want to write your answer as the quotient. And remember, your quotient is what you got above the division bar, x minus 6, plus the remainder we got was 0, over the divisor, which was x minus 2. Shoot. X minus 2. There it is. So there's your answer. But, you know what? A lot of times on these, if you have a 0 remainder, usually they'll just write the quotient, because there is no remainder, so you really went in evenly. Let's say x minus 6 times. I think you only really have to write it like this, with the remainder over the divisor. If the remainder is something significant, something other than 0, that's when you actually have to worry about it. But in this one, there was no remainder, so I just say it goes in x minus 6 times. That's it. Okay, so we divided. That sounds good. Let's try part B now. This process is very tedious and, I don't know, and very confusing, especially if you're not used to it, and I don't know, if you're not careful, this is very complicated. So the more of these you do, the better you'll get. It's very, very tricky. That's why it's the last section in this chapter, I guess, because we saved the best for last, right? The most complicated for last. Now let's try part B. I notice, like, step 1 says you're going to write the divisor outside the bar. I'm going to write it up here because I want to leave more room for myself. Okay, and then the dividend, 2x squared plus 11x minus 5. I got lucky because they gave me both polynomials in descending order of powers. They're both in the perfect order, and also you notice that there's no missing terms because I have a square, or that's a second power, then a 1 power, then a 0 power. There's no missing numbers between 2, 1, 0. Same thing here, a 1 power and a 0 power, so nothing missing. I don't have to worry about that. I'll move on to the second step, which is I'm focusing on the first term of the divisor and I'm focusing on the first term of the dividend, and I'm dividing those guys. X goes into 2x squared how many times? You can kind of go off and think about that. How many times can x go into 2x squared? Well, if I subtract their powers, a 2 power minus a 1 power is a 1 power. So that would be the quotient there. X goes into 2x squared 2x times. Or another way to think of it is, instead of saying what's x divided into 2x squared, you can always say, what would I have to multiply x by to get 2x squared? That's another way to say it. You could say x times what is 2x squared, you know? And then you get the same thing, 2x. It's kind of up to you how you want to think of it, but either way works. Alright, now that I've found at least that portion of the quotient, now I'm going to take that 2x that I found and multiply it by every term in the divisor. There are 2 terms in the divisor, so I have to multiply twice. First the 2x times the x, that'll make 2x squared, and then the 2x times the 6, that'll make 12x. Alright, we're doing good. Now the next step is to subtract, but I've got to be careful and I cannot forget my parentheses. So if you want, you can leave it this way. 2x squared minus 2x squared is 0. Those cancel. And then you have 11x minus 12x squared. 11x minus 12x is negative x, or negative, if you want, you can write negative 1x. But I think it's too tempting to say, like, look at this and say, oh, it's 11x plus 12x, and write 23x. So I think I would always, like I said before, distribute the negative, make sure you change that sign. That way it's clear it's 11x minus 12x, not 11x plus 12x. So anyway, you get negative x, and then the next step is to bring down the next term. I haven't used the negative 5 yet. And that's a good sign. I'm bringing down the very last term, so I'm almost done with this problem. Now I have to divide again, or we can kind of use that, the other way we said it. You could say this x here, instead of saying x goes into negative x how many times, you could say x times what is negative x? Well, x times actually negative 1 is negative x. Or if that's too weird, you can do the division off to the side. I'm dividing x into negative x. And then I'll simplify that. Negative x over x is negative 1. Okay, so that must be the quotient that I want. That's what I placed up here at the top. And now I have to multiply that negative 1 by both terms in the divisor. Oops. Both terms in the divisor. Negative 1 times x first, and then negative 1 times 6. Alright, so I've got negative 1 times x. That's, you could write negative 1x or negative x. It's totally up to you, whatever makes it easier. And then negative 1 times 6 makes negative 6. Now I'll have to be really careful. I'll put the subtraction sign here. And this is where I have a lot of negatives. This is where it's probably a good idea to actually distribute that negative sign. Because otherwise I have to say negative x minus negative x, and then negative 5 minus negative 6. Oh, that's confusing. So I'm just going to go distribute this negative. It makes this guy a positive. And distribute that negative. It makes this guy a positive as well. And then you're just combining vertically. This and this, this and this. X and negative x cancel. There's nothing left. But the negative 5 and the 6 add up to 1. That must be our remainder, 1. Alright, and as the last step of those directions says, you want your answer to look like the quotient, which was 2x minus 1, the thing that's above your division bar, plus the remainder. This time we actually got a remainder of 1 over your divisor, x plus 6. And that's how you're supposed to write your answer. That's the quotient, yeah, like it says here, quotient plus remainder over divisor. So there it is. And there's not, it's tough to check your answer on these. You might want to just do the whole process over again, being really careful. I'd say that what's really important in these is writing as neat as you can. Don't rush through it, or else you won't be able to read your own writing and you'll mistake a negative for a positive or vice versa. And don't write too small, because if you write really small, you won't be able to see what you wrote, and anyway, you might mess it up. So write large and write very clearly, write slowly. Alright, let's try part C here. This one looks kind of interesting. We got some t's. That's kind of fun, huh? T to the 4th minus 2t squared plus 4t minus 5. Ooh, you notice, before I even do anything, I'm going to write, you don't have to write this out, but just so you notice, this is missing from the highest power, which is a 4, to the lowest power, which is a 0. I don't see a third power. That's somewhere in between. But I see every other power. You know, you have a 4th power, I don't see a 3, but I do see a 2, I see a 1, and I see a 0. But I'm missing a third power. And then the one I'm dividing by, t squared minus 3, the highest power is a second power, but I don't see the 1 power. That's the missing term. So both of these have a missing term. That's kind of tricky. So remember, you should see from the highest power to the lowest power, every power in between. So from 4 to 0, which is the degrees of the first polynomial, I should see 4, 3, 2, 1. And in the second polynomial, I have a degree 2, so I should see 2, 1, 0. Alright, so I got to keep that in mind. When I write this out as division, I'm going to say the divisor is t squared minus 3, but I have to put something where the t term would be. So instead of t squared minus 3, I actually have to write t squared plus 0t minus 3. And that is essential. These problems won't work out if you don't do that. And then the same thing with the dividend. I have t to the 4th. The next power should be a t cubed, but I don't have one. But I can just insert kind of a fake little 0t cubed. It's just kind of like a placeholder. That's like a little ghost. 0 times anything is 0. So when I add that, it's just like throwing a ghost in there. It doesn't represent anything. It's not real, but it looks like there's something there. And then after, let's see, t to the 4th, then there was a t squared, negative 2t squared, 4t minus 5. There we go. So be really careful. It's essential to write those missing terms. Alright, now that I have those there, I'm ready to go for it. I'm going to focus, like I said before, on the first term and the first term. And these ones, I think you can kind of do it in your head, especially if you think of it as, instead of t to the 4th divided by t squared, I always ask myself, t squared times what would be t to the 4th? Well, you need another t squared, because t to the 2nd power times t to the 2nd power, if you add their powers, would be t to the 4th power. Alright, then I'll need to take that guy, oops, sorry about that. Take that guy, multiply it by there are 3 terms now outside in the divisor. I'll have to divide, or multiply it by all 3. So t squared times t squared, that'll be t to the 4th. T squared times 0t, even though it's a 0, just pretend like it means something. It'll be 0. T squared times t is t cubed if you add the powers. And then t squared times negative 3, the last guy, would be negative 3t squared. And you notice now that there are like terms that are above each other, right? You got t to the 4th, t to the 4th. So when I subtract, those are like terms, and I can actually combine those. You have t to the 3rds, those are like terms, I can combine those. And then t squareds. But if I didn't have these placeholders, I would have, my terms would be kind of lopsided, and vertically I wouldn't have like terms. And I would be kind of stuck, because I couldn't combine 2 terms that don't have the same exponent. Alright, now my next step is to subtract. I better be careful here. Subtract this guy. Like we said before, I'm going to distribute that minus sign. Make this guy becomes a negative. This guy also becomes a negative, but this guy will become a positive. And then I can kind of forget about that subtraction sign. It's already been taken care of by distributing. And now I'll combine vertically. We have a t to the 4th minus t to the 4th. That's nothing. And you know what? At this point, I'm going to just point this out. The very left terms when you subtract should always cancel. If those don't cancel, that means you divided wrong. This t squared up here was probably the wrong thing. So the left ones should always cancel. The next ones maybe, maybe not. But then you have 0t to the 3rd minus 0t to the 3rd. That's nothing. So those actually cancel. That's not always true, but in this case it is. The last guys here, you have negative 2t squared plus, this is now a plus, it was a minus, now it's a plus. Negative 2t squared plus 3t squared, that's 1t squared, or t squared. Alright, now you want to bring down the next term. And you know what? This one, let's see, if I bring down the 4t, yeah, let's just do it. Okay, bring down the 4t, and then we'll do it. This will be, I think this will work out pretty well. Now we're dividing, remember the first term in the divisor, t squared, into the first term we have here. T squared divided into t squared, or you could say t squared times what is t squared? Well, t squared times 1 would be t squared. That would work. Or if you don't like that, you could do it the way we did before. T squared divided into t squared is 1. Reduce it like it's a fraction instead of division. Alright, now that I have the 1 up there in the quotient, I'm going to go ahead and multiply that 1 by all the terms that are outside the division bar, all the ones that are in the quotient here. 1 times negative 3, 1 times 0t, 1 times the t squared. But I'll go from left to right. 1 times t squared is t squared. 1 times 0t is 0t. 1 times negative 3 is negative 3. Alright, so that looks good. But But you notice now that I have it here, I'm going to try to subtract what I just wrote from what's above it. But the negative 3 won't be able to, he's not below anything. I don't have anything to subtract from him. So now at this point I realize I probably should have brought another term down. That way the negative 3 that I have in the red writing actually has something to combine with. So there'll be sometimes where you bring one term down, like we brought 4t down. If you don't notice that you're supposed to bring the next term down, that's fine. You'll notice when there's kind of something missing. We had nothing to combine the 3 with. So anyway, it's possible you want to bring 2 terms down instead of just 1, but you don't have to notice it right away. You can kind of notice it later. Alright, now I'm going to subtract, but I'm going to distribute this negative. That negative will make this t squared negative. It'll make this 0t negative. And it'll make this negative 3 positive, actually. And then I can forget about it now that I've distributed it. Now I have t squared minus t squared, that's 0. And again, we said, if that happens, you know you did something right. If those don't cancel, something went wrong. You probably divided wrong. And then I have 4t minus 0t, that's 4t. And then negative 5 plus 3 now, since the negative changed to a positive. Negative 5 plus 3 is negative 2. And now since there are no more terms to bring down, I'm all done with this problem. My answer is the quotient, which was t squared plus 1, plus the remainder that we just have at the bottom, 4t minus 2, over the divisor, which was t squared. I could put the 0t minus 3, but at this point, since I'm just writing my answer, I don't really need the 0t. The 0t was kind of only there to make the division work nicely, but now that I'm done with the problem, I don't really need the 0t. It's just kind of there as a tool to get me to my answer. Whew. And yeah, like I said, the bad thing about these is there's not really a way to check your answer on these. You just got to be really careful. If you want to be really careful, let's say you're taking an exam, one of our midterms, I would probably just, wait till the end of the exam if you have a little more time. Try this problem one more time, because these problems, I swear, I'd say on exams, probably a third of the class gets it wrong because they made one little mistake. And that's quite a big part of the class. A third of the class, that's a lot. And it's usually, like I said, where in this distributing of the negative, people forget to distribute, or they distribute it wrong, or something little like that. So be really careful. This would be the one I'd really want to check my answer in. Alright, let's try this last one. This one here is probably as bad as they'll get. This way, if you can do this one, you can do any problem. I'm looking at my dividend here. I notice not only these terms are in the wrong order. I want to see the highest power first, and the highest power is a 4. But then from there, I'd better see every successive power from there. I should see a cubed, I should see a square, I should see an x, and then I should see a constant. But you notice there is no cube term there, so I'm going to have to put a 0 like we did in the last one when there's a missing term. There is a squared term, it's negative 3x squared. There's an x term, it's just a regular x, and there's a constant 4. So I'm just going to rewrite it once to... So it's all right in the correct order, and then I have my missing terms ready, and then I'll write it as a division problem. And then the dividend, that was the dividend, this is the divisor. The highest power there is a square. So I'll put that first, and then from there I should see every successive power. There should be an x, but there is no x. So I'll put a 0, and then the constant term is there, it's a 1. So that's really what I'm dividing when I'm really getting down to it, and putting all the placeholders there so the division works out nicely. Alright, now I'll set this up as a long division problem. I've got the divisor 2x squared plus 0x plus 1. I'm dividing that into this crazy big dividend, 6x to the 4th plus 0x cubed minus 3x squared plus x minus 4. Alright, we'll try this guy here. But now that I look at this is sort of similar to the last one, because the last one was some kind of t squared divided into some kind of t to the 4th. So I think this problem will be about the same length as the last one. Yeah, if you have the same powers, a square into a 4th like the last one, it would probably be about the same length. Alright, but again, we focus on the first term and the first term. And I can either say, what's 6x to the 4th divided by 2x squared? Or I could say, 2x squared times what is 6x to the 4th? I think if you want to be really careful, you're kind of a cautious person, you can always go off and try it. Like, I'm dividing 2x squared into 6x to the 4th. Let me reduce that. 2 goes into 6 3 times. If I subtract the powers on x, I get a square. So that must be how they divide. It's 3x squared that I want. There he is. And that quotient is going to be multiplied by every term in the divisor, all 3 of those guys. And whatever I get, I'll write it below the dividend. 3x squared times 2x squared is 6x to the 4th, which that's how I designed it. It's supposed to be the exact same as what's above it now. 3x squared times 0x, well 3 times 0 is 0. X squared times x is x cubed. And then the last guy, 3x squared times 1 is 3x squared. And now we'll get ready to subtract those guys. Subtract in parentheses, excuse me, and then I'm going to distribute that negative. That negative will make the 6x to the 4th negative. It'll make this 0x negative, not that that matters, because negative 0 doesn't mean anything. And then the negative on this 3 will make it negative as well. Alright, now I can just combine vertically. So now what do I have? 6x to the 4th minus 6x to the 4th cancel, which this is kind of where you're checking, did I divide right? If those cancel, then you did divide right. What's left now is 0x to the 3rd minus 0x to the 3rd. We got lucky and those cancel as well. Those don't always cancel. And then we have negative 3x squared minus 3x squared. That's negative 6x squared. And then if you hadn't subtracted, or you hadn't distributed the negative, you might have thought that's still a plus. If you thought that's still a plus, negative 3 and 3 would add up to 0. And you'd be left with nothing right now, and that would be kind of scary. Alright, so we've subtracted. Now I'll bring down the next term. We haven't involved this x yet here. I'm going to bring him down. And maybe in the future it might be necessary to bring the next term down at the same time, but I'll just see. I'm not going to worry about that now. I'll see if I need it later. Now I'm dividing one more time. I'm dividing the 2x to the 2nd power that's in the divisor into my leading term here, the negative 6x squared. But you can always try that, like we said, divide it over here. You're dividing negative 6x squared, squared by 2x squared. The x's just cancel. Negative 6 divided by 2 is negative 3. So that must be what we want in our quotient there. A negative 3 or a minus 3. So okay, and then I'll multiply that 3 there, and think of it as negative 3, not just 3. Negative 3 times all the things that are outside the division bar and the divisor. So first I got negative 3 times 2x squared, that's negative 6x squared. Negative 3 times 0x is, well, negative 3 times 0 is 0. And then you have an x attached. And the last guy, negative 3 times 1 is negative 3. And I realize now, when I try to subtract this, I don't have anything to move or to combine the negative 3 with, so I should have probably brought that 4 down. But don't worry about, if you didn't recognize that until now, that's fine. It's not a big deal. Now I'm going to subtract these guys. So let me put a minus sign in front of everyone, and then I'll distribute that subtraction sign. That subtraction sign on this negative 6x squared will make it actually a positive. The subtraction sign on this 0 will make it a negative 0. The subtraction sign on this negative 3 will make it a positive 3. So really when you subtract, just change everybody's sign in that parentheses, and you should be good. Now I'll combine vertically. Negative 6x squared plus 6x squared is 0. Those disappear. And you have x minus 0x. Well, if you think about the coefficients, that's a 1x minus 0x. So you're taking 1 minus 0. That's still a 1x. Or you could just write x. And then in the last terms, you have a negative 4 plus 3 now. Negative 4 plus 3 is negative 1. And there's nothing left to bring down. I've already brought down the last term here, 4. So I'm done. But I'd probably write this guy as x minus 1. Not 1. If you write 1x, that doesn't look nice. That's not finished. I'm just going to leave him as x minus 1. And then we know how to write our answer by now, I think. It's the quotient. Uh-oh, I lost it. What was above the division bar? We got 3x squared minus 3. And then our remainder we just found was x minus 1. And that's over the divisor, which was 2x squared plus 1. We don't really need the 0 anymore. The 0x. That looks good. All right. I like it. So I think this process is very confusing and very complicated. It's easy to make mistakes, but I think the more of them you see, the easier it gets. And the more of them you try, the more confident you get, and the less likely you are to make mistakes because you're careful, you know? And I know maybe it sounds silly too, but somehow when I use color, it makes more sense for some reason. Especially when I distribute the negative. You know, notice up here, when I distributed that negative, I don't know if I would have remembered which sign was the new sign that, you know, the subtraction changed to, unless I did it in a different color, and I was looking for that color as opposed to the old color. So it seems silly, but if you want, you can bring color pencils or highlighters or markers or whatever to the exam or the midterm, or do that in your homework, do that in your notes. It's not a bad idea. I think when I added color to my notes, even math notes, That was like a game changer for me. I didn't mind reading them later on to study because it was prettier, and it was just easier to read and stuff. So hopefully that makes it easier for you too. We'll see you in the next chapter. It'll be a little easier, and like I said, it'll be very useful. You'll be using this for all your rest of your math classes. So I'll see you then. Thanks for listening. Have a good day.